Oh, let's see. How's it going? Uh,
Hi,
Hi, how are you?
good. How are you?
Good. Let's see. I'm trying to make sure that I have everything ready. Yeah, do you have any questions or anything that you for sure want me to talk about today?
No, I started on my practice quiz and I got
No.
up to question 8, like all correct. So,
Okay.
and I rewrote like all my notes, so I'm pretty good, like with all the past stuff from Tuesday.
Oh, good. Yeah, so that I will say that, yeah, that's a good thing. Then it's just, like if you like got those all right and then you rewrite those
Yeah,
notes, then like when you go to, if you have it all in front of you, taking the quiz and doing the homework will be fairly easy.
yeah, I rewrote all my notes to make it more clear to me, and
Yeah,
like now it's much more like simpler, you know?
yeah, yeah, like it is. It really is. All right, Amber, are you doing okay? If you have any questions, if you don't want to say anything, you can put them in the chat too. That's fine. It doesn't matter. I'll look at both. uh, I'm just closing out this other window from my last class because they talked and talked and talked and talked and okay, here we go. So all right, then we can just start at 9, and then if you think of anything, let me know. So this one I'll say is where it comes into play, like the idea of like keeping everything straight. And so if you look at this one here, then the capital letters are usually the angles or the Greek letters, and then the lowercase letters are the lengths of the sides. So then I was actually looking for one other thing in my paper so that I know where the section is in the book, because I think this one is still 7.2. So it probably is, but yeah, this one is still 7.2. So here it is. Yeah. So now the one thing that I did want to point out is that sometimes the wording will just be, instead of say find the values of the remaining parts of the triangle, they'll just say something like solve triangle ABC. So when they say that, they just mean the same thing as like find the values of the remaining parts of the triangle. So I do think that that's part of the confusing part, is just that they could say the same thing but in lots of different ways. So then if they have that the gamma right here is 90 degrees and that the alpha is 62 degrees, and then that the A is 11. So that means that this length is 11. Then find all these other things. So this is 62 degrees and 90 degrees and 11. So the first thing then that I would do is, now I wouldn't say that I would necessarily find these all in order, but you you definitely could. but usually the one where you're just finding the degrees will be easier. So that's because if you add these all up, the alpha plus beta plus gamma, they have to be 180 degrees because that's the some of the angles in a triangle. So then because one of the angles is a right angle for sure, then the other way you could say this is just that, right, since that one right there was 90, then alpha plus beta is 180, right, minus 90, so just 90. I should, right, would be easier if I just write 90 rather than 180 minus 90, but 90 degrees. And so then if that one alpha is 62, then 62 degrees plus that beta is 90 degrees. So beta is 90 degrees minus 62 degrees. So beta would end up being the 18 degrees. So that one is that. Do you have any questions about that one? Or because that, like the sum of the angles being 180 or the Pythagorean theorem, there are just like the standard things about, say, trigonometry and triangles that come up. Oh, I was actually going to look real quickly at something somebody sent me like super late last night. They said that they were working on one of the problems in the homework and then their decimal answers kept on being off. So I'm just trying to see like where the person was actually, what the person was actually talking about. So I don't know, but let's see. So where was it? Because I didn't, that wasn't that one. And it was probably like, yeah, it was one of the ones from the homework that they said that they kept on getting like a answer that looked like it was really close, but it actually wasn't. So it, like, so I just want it to like go and actually just go over that one for the record, just because it's very like similar to, I don't know why these keep on popping up because this is, it's really bothering me because it's the same type of problem that we're doing here is why I'm even mentioning it. But anyway, so that would be the easiest one to find. And then if you want to find the B or the C, then what I would say is that there are definitely multiple ways to find it. But if you look at the 62 degrees, then this side is actually adjacent to alpha. This side is opposite from alpha, and this side is the hypotenuse. So if you want to find B, then you can go and do what we did the other day. And so if you want to find the adjacent side, then it would be the opposite side times the cotangent of theta, or you could do opposite side divided by the tangent of theta. So then what I would do is say that B is the side that's adjacent to alpha, so then you would do the opposite divided by tangent of theta. So the opposite side was 11 and then theta, right? Or you could call it like alpha in this case, but it would be tangent of 62 degrees. And so my printer is just like malfunctioning, so I guess that's is what it is. So then like, my calculator then would tell me as long as I'm in degree mode, then 11 divided by tangent of 62 is going to be, where is it? Because I don't actually know where. It's not really. I feel like I actually put, yeah, I have my papers all in the wrong order, so I don't know. Really, like I don't know what happened here. So anyway, I just want to make sure I had the decimal already written out. So I wouldn't have to like see how many decimal places that they would want you to round to, because I don't think it said. So I don't want you to like get to that and then not know. So yeah, it doesn't really matter. So I would just, oh yeah, it does say round to two places. That's why I was looking for, is in the instructions, like round to two places. Where was it? Yeah, two places. So then since this was actually 5.848803748 to two places would be right here. So that would round up to 5.85. So B is 5.85. Do you have any questions about that or anything? Because this all builds on what happened the other day, just in a different way. Now you're just have to find everything all at once. So I don't think that's too bad, but oh, you know what? Sorry, this is 28. My subtracting is that bad. I looked at it again. 90 minus 62 is not 18, 28. I don't know how this happened, but yeah. All right. So let's actually go then and find C. So if you want to find the hypotenuse, then what I would probably do is go back to the other day and the different formulas for the hypotenuse. And one of them was, well, opposite over sine of theta. So that would be opposite over sine of alpha in this case. So 11 over sine of 62 degrees, and 11 divided by sine of 62 degrees would be approximately 12.45827.056, but to two decimal places, that would actually round up to 12.46. So 12.46. So that is actually all of the ones, or all the problems for 7. Wait, no, there's one more. Sorry, number 10 is from 7.2 also, I think. So, yeah.
So to
Alright.
find, sorry, so to
Oh,
find
yeah.
B and C, we would just go back to that formula list and then
Yeah.
plug in one of the like we can use any formula or
Yeah, you could use, well, so if I'm finding B, you could, but if I'm finding B, I didn't know the hypotenuse, so I probably would use like that one, but I can't, like, I picked this one down here because I can't really find cotangent in my calculator. So I
yeah,
just
yeah.
went with that one.
So pick like the easiest one,
Yeah,
like
pick
the
the
most.
easiest one to do.
Okay,
Yeah,
perfect.
so that's why I think like, yeah, like writing out the list of formulas like that can be helpful, but that's something like that, they just don't do that in the books. Like not just in general, books don't do things like that. It wasn't this one because that was the one where I had the answers on it so that I can make sure that I rounded the decimals in the right amount of spots. So 10. All right. So this one is similar, but then let's see. So the given triangle has gamma is 90 degrees, alpha is 72 degrees, and B is equal to 8. So you have gamma 90 degrees, alpha 72 degrees, and the length of B is 8. And so what you want to find are the hypotenuse, and you know that B is the side that is adjacent to alpha and A is opposite from alpha. So same idea, but now they give you the adjacent side. So they, in a problem like this, just want to make sure that you essentially, I hope you see, like, they're just trying to give you practice of all the different formulas and then go from there. But the easiest one is still to find the missing beta first, because the alpha plus beta will still be 90 degrees. So beta will be 90 degrees minus 72 degrees. So this one I think is 18, right? Yeah, the last one I think that's what happened on the last one actually, is that like, because it didn't have the number at the top, I swear that I'm getting all of these pages, like they're all blending together. So I probably should just label these so that I don't look at the wrong page, but here we are. So then that's 18, but you can then say, well, if you want to find A, then A is opposite from alpha. So then if you go back, if you want to find something that is opposite, but you know that B is adjacent to the alpha, then you could use that one right here. So it's the adjacent times tangent of theta. So adjacent would be the 8, and then, well, alpha again, but you can use any angle but alpha. So tangent of 72 degrees. So 8 times tangent of 72 degrees is 8 times tangent of 72, 24.621468. So to 2 decimal points, 24.62. So A is 24.62. Do you have any questions, or do you feel like this is reasonable to just work your way through these? I'm looking for my yellow highlighter. I don't. Oh. Yeah, so I don't think that these are too bad once you get used to them, but that list of formulas can be, overwhelming at first. Moving this over here. Okay. Then C is the hypotenuse. And so then I probably, since I know that B is the adjacent side, just do adjacent divided by cosine of theta. So that would be the 8 divided or alpha. I don't know why I just write the generic angle in there, but 8 divided by cosine of 72 degrees. So that would end up being the 8 divided by cosine of 72, 25.88854,382, and then round to 2 decimal places, so 25.89. So 25.89. Any questions or anything like just maybe even anything you were wondering? So is because it, it always could be worse. I mean, it wasn't too bad, hopefully. Then let's see. Where is number? I know we don't have that many of them left, so I want to make sure that I don't like skip over anything, but I don't know where I put the rest of it. Okay, 7.3, 7.3. Okay, so the next one is also from 7.2 then, and it's again still the same idea, but just like, and at this point, like I will say, right, that there's only so many ways they can ask things. So I will say that they also are giving you the 90 degrees and beta is 79 degrees. So the only thing that's a little bit different here is that this angle I've been using down here is the one that's actually missing, but that doesn't really matter because you could just still like find out what that alpha is and then do this all the same way as the last problem, so it really doesn't matter too much, but this alpha then, remember, like alpha plus beta is 90 degrees, so alpha will be 90 degrees minus that beta, or 90 degrees minus 79 degrees, so 11 degrees. So that's 11. But then from there, you can just go and do this really the same exact way as the rest of the problems. If you like the previous problems, you could just say that this one is actually adjacent to alpha. This one is opposite from alpha, and this one is the hypotenuse. Now, if you did it a different way and based it off of the 79, which is what I think that that's what they do in the solution. If you look at the one on the, when they give it to you online, they would base it off of the 79, but you don't have to. You could find the 11 first, the alpha, and then do it the same way as in the last problem, because then B would be adjacent to alpha, so then it would be the opposite. Well, actually, which side do you actually know? You want to actually know. Oh, you actually, I thought that this last one was I was looking at, actually, I'm looking at the one that was, I thought this was the one where we were given the alpha A and not B, but if you want to find A, then it would be like number 10. So opposite from alpha, so adjacent times tangent of alpha. And then C would be the hypotenuse, so adjacent over cosine of alpha. So really, this isn't hopefully a surprise. Like once you find that 11, you do the same thing as in problem 10. So this would be adjacent 11 and then times tangent of 11 degrees. There's a lot of there's a lot of 11s here. So 11 times tangent of 11 degrees, that's about 2.138183401. So yeah, sorry. And then if I round this, this is 2.14. And then this one here would be 11 over cosine of 11 degrees. So 11 divided by cosine of 11 degrees is 11.205888364. So to two decimal places, about 11.21. So those will be my answers. A is 2.14, C is 11.21. Any questions, Christina, or anything that you want to see again?
Um, no, it's pretty like understanding. You just said when you wanna like for degrees, like that's understandable. You just do alpha plus beta equals 90 and then calculate the formula out. But for A and C, you just like if A is opposite from alpha, we usually go back to the opposites formula and we pick one and then you go from there, right?
Yeah,
Basically. Okay, yeah, that makes sense.
yeah. So this, it's just, it's not too bad. All right, then let's see. Let's look at question 12 then. And 12 is from 7.3. And so this is actually one of those things where I, yeah, it was one of these things where I know that this is a like a difficult concept, so I really, I wish that I would have just uh I don't, so I'll have to like give you that sheet still somehow because I tried to upload it to Canvas and I don't know where it went to, but just in general though, I'll show you what is going on. So really, if you have, I need like a unit circle diagram because I feel like if um you either like have one or you don't have one, and I know that there are some really like nice ones out there, but this one is a little bit blurry, so I don't want to like pick one where it is, huh, actually, you know what, I'm just gonna like print out like the polar graph paper for a second because it's the end of the class will be about something called like polar coordinates. And so that might actually be like, I kind of have an issue in a little bit of a way that I sort of really like wish that it would be like one way or another, but I wonder if I can just save this. If I can save it, because they you know how websites want you to pay. So I really don't want to pay for something that I think should be free for you. So here, I think that I can show it to you on this. I don't want to draw it because I feel like that would be an even bigger disaster if I tried to draw it for you. So, all right. Here it is. So, all right. So here's like a graph and it's labeled in radians. So it said if t is 2 pi over 3, determine the quadrant in which the unit circle point P of t lies. So t is 2 pi over 3. So all you really need to do is think of this as just the coordinate system like it normally is. So here is the x-axis and here is the y-axis, and then here is right there is 2 pi over 3. So if you go around this far to around the circle right here to 2 pi over 3, then you are in quadrant 2. All right, so this is really just asking like the same thing as like in 7.1, but they're having you actually look at it on a circle rather than like on a grid without a circle, if that makes sense. So a unit circle just means, right, a unit circle just means that this is, like if I did that, it means a circle with a radius of 1. So if you want it to, you could like say, well, there's a radius of 2 circle, there's a radius of 3 circle, and make more and more circle larger and larger. But really, you just need to find out where that 2 pi over 3 is. So do you have any questions about that? Because I don't think that this is that bad, but it could end up being, bad if you don't know. And then like again, it's all like notation. Like once you're used to it, I think you're used to it. All right, the next one asks about the negative 31 pi over 6. So then find a real number t in the interval 0 to 2 pi such that p of that t equal p of s. So p of t equal p of negative 31 pi over 6. So that's saying that that s was that right there. So if you do that, then in the same way as before, like if this is say the pi over 6, then you would actually, you could go back and say, well, that's 0, and then negative pi over 6, and then you have to be kind of careful here, but this is negative 2 pi over 6, right? The 5 pi over 3, and then you have the, where is it? Sorry, I'm trying to like see these because they're really, really like just bothering me that they're so small. Okay, so then this one right here would be negative 3 pi over 6, and then the next one would be negative 4 pi over 6, then negative 5 pi over 6, negative pi, of course, then negative 7 pi over 6, then negative 8 pi over 6, negative 9 pi over 6, then negative 10 pi over 6, then negative 11 pi over 6, negative 2 pi. So then if you see how this is working, then you keep on going around till you get to the negative 31. So this would be negative 4 pi or negative, what is it, like 6 pi. So just like think about it like that this would actually be negative 3 pi, negative 5 pi. But if it helps, like you don't really need to go around like and list them all out. Like if you think about it, that this one would be, this is really like what is it, like 6 pi over 6, and then a, if you do that, what is it, 18 pi over 6, and a negative, it really is one of those things, like it's 30, right, 30 pi over 6. So if you kept on going around, this one would be the negative 31 pi over 6. Do you see what I mean? So like, so then that would be like you're going around starting from here once, and then a second time, and then a third time, and then you come back over here. And so the number that's between 0 and 2 pi that's equal to this one right here would be 5 pi over 6. So then you would just answer 5 pi over 6 for that one. So another way, of course, to do that would just be to take the negative 31 pi over 6 and then add 2 pi. And then that's really negative 31 pi over 6 plus the 12 pi over 6. So that would be negative, I don't know, what is it? It's it really is like 19 pi over 6. Yeah. Yeah, that seems about right. And then you have negative 19 pi over 6 plus the 2 pi. If you do that again, same idea, then you have that negative 7 pi over 6, and then you have to do it again, negative 7 pi over 6 plus 2 pi. So that's where you end up with the 5 pi over 6. So you would just keep on adding 2 pi until you get to a number that's positive. So like, but in my opinion though, like if you want to visualize it like going around the circle 3 times, you could do that too. So either way is fine. Like it, you just keep on adding 2 pi until you get to some number that's positive. So this is just when they say like the P of T and P of S, that is just there to worry you a little bit. But the fact of the matter is Yeah, like it's the same notation, different thing. Oh, let's see. All right, so then 7.3, so A, then this one is what is corresponding to -15 pi. So I would say that if you are looking here and this is the unit circle and this is the point of the 1 0 and then 0 1 and -1 0 and 0 -1, then you could figure out where the -15 pi lies on the circle the same way as in the past. Like you have 0, then you want to go negative. So -pi over 2, -pi, -3 pi over 2, -2 pi. Then this would be over here, right? -3 pi, then -4 pi. So if you think about what's going on though, like all of the odd numbers are over here and -15 is odd, so it better be the -1 0. So I don't know where I put that, but -1 0. So do you have any questions about that? And like I don't think it's that hard to go around there. Like you have to go around like another 7, 9, 11, 12, 13, 15, and just do that. But I don't think it's that bad. I was just looking for where I put these other ones though. Okay. So then the last one here, it says if P of, and its square root is 65 over 10 and square root of 35 over 10 is P of T as a point on the unit circle, then find sine of T and cosine of T and tangent of T. So these actually are not going to be too difficult for you, like hopefully, but they're just going to be formulas where you are just oddly enough, like you have to remember them, but I I want to be clear on the fact that this like these formulas right here, the reason why people get confused in later chapters is because these formulas only work if this is the unit circle. So if you have a circle with a radius other than 1, then you have to use a different method, or like a slightly different method. So you have to make sure that the circle is with radius 1. So what I have here then is if the circle has radius, yeah, if the circle has radius of 1, then all right, so that would be again the 0, -1, 1 0, 0 1, -1 0. Then what I would say is if you look at this point right here, it is actually x, y. So if I find the decimal approximations, square root of 65 over 10, that's about 0.8 0.06 and square root of 35 over 10, that's about 0.592. So 0.86, so like 1, 2, 3, 4, 5, 6, 7, 8, 9. So 0.86, 0.56. So this would be the point P right there. So that would be that point right here. So what I'm actually saying is if I were to zoom in on that a little bit more closely, right? Just in terms of drawing this, and I don't actually know if I want to, I guess I probably should say this because it really, yeah, I feel like you need to like hear it in this particular way. Like, okay, so yeah, I need to draw this a little bit bigger just so that it's clear, more clear what is going on. So, okay, so I do want you to see this, but if it's like 0.1, 2, 3, 4, 5, 6, 7, 8, that's like 0.891, and then 1, 2, 3, 4, 5, 6, 7, 8, 9, 1, 1, 2, 3, 4, 5, 6, 7, 8, 9, -1, 1, 2, 3, 4, 5, 6, 7, 8, 9, -1. So if it's this circle right here, and then this is the 1, 2, 3, 4, 5, 6. So it's like right, yeah, so it's like right here. So this is the square root of 65 over 10 and square root of 35 over 10. So that's like P of X, Y right here. All right, so here's how this all works in a bigger picture sense. So this angle right here is actually like angle, that's angle T. So that's the T that was like that P of T. All right, so but so if you're wondering like why it was like P of this equal P of T, why there's like two numbers here and one number here, that's why, is that this is the like the T, that angle. And so then that, and again, that's really not necessarily a like a the nicest way to write that, but the issue is that if you draw the triangle like right down like this, well, think about how this works. Like this length is 1, this length is 1, this length is 1, this length is 1, this length is 1. So the like because this is a unit circle, the radius is equal to 1, which means that the hypotenuse of this triangle is equal to 1. So that's why like that's why I was saying that the formulas are different if the circle isn't a radius of 1, because when the circle is a radius of 1, that means that this hypotenuse is 1. And so when you like, like when you divide by 1, you get the same thing. Or if you multiply by 1, you get the same thing. So it's like, it's really like a hidden one, and you just don't talk about it, because when you multiply or divide by 1, you get the same thing. So this is why that happens, because this is 1, that's 1, that's 1, that's 1, that's 1. So make sure like this is 1 and that's 1 and that's 1 and that's 1 and that's 1, or else what these formulas are don't work. So if this is the unit circle, then really what happens is that the where is it? Yeah. Then sine of t will just be the y value. Cosine of t will be the x value. Tangent of t will be the y over x. And then the, what order do I want to write them? Cosine of t will actually, well, I did cosine of t, so I don't know why I want to write them again. So I'll just make that one cosecant. Cosecant of t will end up being the 1 over y. Then secant of t will be 1 over x, and then cotangent of t will be x over y. But only if the point is on the unit circle, or a circle with a radius of 1. And that's the part that they don't explicitly like say anywhere in a book. They're just like, well, they just use a p of t and p of xy notation and then just leave it at that. And then people are left being like, well, why isn't that the case all the time? Well, it's because like sometimes the radius might not be 1. So, and what do you do, right? So I will say that another way that people write this is p of, because x was cosine of t, like cosine of t, sine of t. So that's where, like I said, like people get their misinformation from is this. So if anything, just like I remember that I stressed a lot here that it has to be the unit circle. So then that would mean then the sine of t, because this was the unit circle, is y. And so that will be square root of 35 over 10. And then cosine of t is x, so square root of 65 over 10. And then tangent of t, and that one was the y over x, so that will be square root of 35 over 10 over square root of 65 over 10. So multiply by the reciprocal. And by the way, like it says you do not need to fully simplify this. So if you left it like this, you could, but that's still like a lot to type in. So I probably would at least like divide out the tens and write it like square root of 35 over square root of 65, like just so that you don't have to write that or type that really difficult expression in. But do you have any questions or anything? Because this is, do you see like how what I was saying like the other day about everything being a formula? Like if you know the correct formula to use at the correct time, you can do most of these fairly easily. But the formulas from the other day only work for right triangles. The formulas for these only work for the unit circle. So I mean, like why are there so many different formulas? I don't know. Like you just have to like start getting used to them. But yeah, if you read through the lecture notes, they will like go through this and talk about, do you see like they don't really say it in the same way, right? And this like just saying that since p of xy equal p cosine of t sine of t, then that sine of t is this and cosine of t is that. That doesn't really emphasize that this is coming from formulas that apply to the unit circle. So that's what I want you to get out of this more than anything else so that you can actually like use this in the later like chapters, but any questions or anything else? Because that's it from the quiz problems. And actually was the last like part of the section 7.3 anyway. So that is all I was, yeah, that's all I was going to say, except for about the if you have questions about the homework or anything else, but feel free to ask. But let me see here, because I do know that if you no, yeah, oh yeah, let's see. I do know that yeah, oh, by the way, yeah, so all right, I do want to say, like, I guess I will make one comment real quickly then about if you're doing the homework or one of these and your rounding isn't exactly right. So let's say on like this one here, let me see here. So let's say on like a problem like number 9 here, if I had 11 over tangent of say 62 degrees, then I, okay, so I'll admit that I I would never actually recommend rounding until you get to the very final answer, because if you did, let's say, for example, right? Well, hold on. I know what I know what I wanted to say, but this isn't a good example actually, because yeah, this isn't the example that I have here isn't actually a good example of what would happen, because but anyway, all I'm saying is what I would do is I would find tangent of 62 and write it out 1.8807264665. And then if you do 11, divide it by 1.8807264665, then you would have 5.8488033748. But if you do 11, divide it by tangent of 62 degrees, and then say, well, I'm going to round first, like even if it's like 1.881, and you use 3 decimal places just to, for example, be on the safe side, then you would get 5.8479532216. And you see, like after 3 decimal places, it's not the same anymore. So this is correct, and this one is like bad, because this is bad. So do not round here, because it's not the final answer. So yeah, just remember, do not round until the final answer. that's one thing I wanted to point out that I didn't say, so do not round until the final answer. So if you get an answer that seems like it's close, but it's like it gives you some error, like it's a little bit off, it's probably because you round it before you got to the final answer. So I didn't say that before. I just, went through and like typed it directly in my calculator for that reason, so that I wouldn't have rounding error. So do you have any other questions or anything? All right, yeah, so just if you get stuck on the discussion or like on the practice quiz or the homework or the quiz, just email me. But otherwise, like next week we'll, do the second half of chapter 7 and go from there. But yeah, try to like have a nice like Memorial Day holiday weekend too, because that's coming up, But let me just stop the recording of